Hi guys, I hope you're doing well. This video is just going to be to introduce you to Lab 6, specifically the simulator that we're going to use. So let me share my screen with you and we'll get started on this. So if you look in D2L underneath the labs folder, there's two different versions of this Lab 6. One's a Word document, one's a PDF document. You can use whichever one's best for you. I will caution you, sometimes on the Word documents, the figures can get moved around. So I would recommend only using that one if you have a specific app that you want to use to, maybe edit it or something like this with the Word document. Now you can print this out, fill it out with pen and scan it to submit it back to me. These will be due on Monday next week. That's Monday the 30th by midnight. There's a Dropbox on D2L form. So you can do the whole analog thing of printing this out, writing on it, scanning it, and then sending it back to me. There's all kinds of scanning apps that you guys can use with your cell phones in order to scan. Or if you've got, I don't know, maybe a stylus and the right kind of software, you can write directly on this and that will save you the headache of printing and scanning. All right, anyway, the lab itself, we're going to be using this website right here from PhET. And I want to point out a couple of things. When we open this up, it's going to take us directly to a website, and we're going to want to set our experiment up to look like this. Let me click on this, and we can see that the windows popped up. Okay, and I want to select lab here. Select lab, and now I'm going to have to move my face. So let's. There I am. I'm down there. Anyway, so we want to click on values. And that's one of the things that the lab told us to do is click on values. And then if we scroll down here, we'll see that the first exercise is to take a 9-volt battery and three ohm resistors and make a circuit out of all 4 of these elements such that there's 1 amp of current through the battery. All right, so let's see if we can at least get started on that. So here's a battery. And we notice it's a 9-volt battery. Let's start pulling out resistors. Resistor 1, resistor 2, resistor 3. Those are all 10 ohm resistors. If we flip back over here, we needed 3 ohm resistors. So let's click on this. There's a nice slider bar down there that I can use to take this to 3 ohms. You guys notice as I click this that the color bands on the resistors change. Those color bands tell us actually how much resistance the resistor has if we know how to read them. So there's 3 ohm resistors. Now I'm not going to do this exercise for you, but I do want to show you how to set things up a little bit. I'm grabbing a wire from my 9-volt to my 3 ohm, or one of my 3 ohms. Let's stretch things out a little bit here. And then another wire to connect these 2 guys together. And then if we connect another wire here, we'll see that we've got electrons moving through our circuit. If we wanted to look at conventional current, then we could click up there on conventional or back to electrons. There we go. Let's work with conventional. Now, this is great. My goal was to get 1 amp of current, but I have no idea how much current is running through this unless I do the math. But we've actually got a meter here, which I'm going to use this one, this ammeter. Ammeter sounds like amp. Okay. So I'm going to put that right in my chain. And when I do that, I see that I've got 1.5 amps worth of current flowing. Now, that wasn't what I wanted, but that's okay. You guys can play around with this and figure things out a little bit. So that was 2 resistors in series. Now, if I wanted to set these guys up so that they were in parallel, let me just start back over from scratch. Move this up here. If I wanted to, whoa, okay. If I wanted to set this up so that I had two 3-ohm resistors in parallel. Hey, look at that. The current flows a lot faster. I wonder why that is. Stick that one there. Of course, we don't have a complete loop on that one, so no current's flowing there yet. And then we stick this here. What do you think is going to happen to the current when I do this? I wonder what that means. But anyway, I've got these two guys in parallel now. And if I wanted to maybe, I don't know, measure the current on that one, I can just stick this in. Whoops, stick this in there. Okay, now I know how much current's going through this particular resistor. Of course, if I wanted to know how much current was going through the battery, what would I have to do? Okay, now I know how much current's going through the battery, okay, because all the current coming from the battery has got to go right through there. All right, that's great. Now, what if I want to, I don't know, maybe measure the voltage instead of the current? How would I do that? Well, I've got a voltmeter here. So I'm going to pull that out. I'll just stick this down here somewhere. All right. And maybe I want to know, I mean, the battery says it's 9 volts, but is it really? Well, let's use our voltmeter to figure it out. Okay, so I always put the red lead there in the front towards the direction, or at least you notice how the red arrows basically are pointing towards the red lead. Yeah, I always keep the red lead in the front of that flow when I'm talking about conventional current. So there's 9 volts across this battery, which makes sense. It says it's a 9-volt battery. Well, how much voltage do I have across? I don't know. Maybe maybe this resistor right here. Let's see now. I'm going to stick with what I told you, which is to put the red lead in front where the other arrows are headed towards. And if I look at my display now for my voltmeter, it says, oh, negative 9 volts. That means that this particular resistor is getting all 9 volts from that battery. Well, okay, well, how much voltage is this one getting? Maybe we better measure this one as well. Oh, that one's also getting about 9 volts. Oh, that's right. If we remember the last lab, we said that if we've got two things in parallel, then both of those parallel lines are going to get the exact same amount of voltage total. All right. I think I've talked enough, guys. I will let you explore the lab. If you run into issues, please get back to me. And then maybe I'll make another one of these, or maybe I'll be able to tackle those one-on-one. I'll talk to you soon. Yeah, talk to you soon.